Hello everyone, this is our session 10 on indefinite integration. We've done some special integrals in our previous session, okay, which was 1 upon x square minus a square, 1 upon x square plus a square, 1 upon a square minus x square, 1 upon root of x square minus a square, 1 upon root of a square minus x square, and 1 upon x root of x square minus a square. So there were 7 of those that we had done. Okay, now there are some special integral types, okay, like which will include quadratics in the denominator. So how will you solve that type? So we'll just go through the steps of it and then we can begin the exercise based on the last two sessions. Okay, so there are three types of integrals that we should know about. So, okay, so our first integral type is, so integral of type okay. So the first type is integration of 1 upon ax square plus bx plus c, okay, dx, or integration 1 upon root of ax square plus bx plus c. So either it's under root or it is just a quadratic in the denominator. So how do we solve this? So there are some steps regarding the same. Okay, so let's look at the steps of solving these kind of sums. So the first step is write ax square plus bx plus c in the form now what is the form that you have to convert it into? So you take a common, that is coefficient of x is taken common, okay, and then you write it as x square plus b upon a x plus c upon a. Okay, we do this. This is our first step. Remember, a should be greater than 0. Okay, then and take root a or a out of the integral sign and take, since it's a constant, right, a or root a in case of the root sign integral, a or root a out of the integral sign. First step, okay. Now what's the second step? Let's go to the second step. It says square plus bx upon a or x square minus bx upon a, okay, is expressed by method of completing squares. Okay, completing squares. How do you complete squares? So by adding and subtracting. What do you add and subtract? Half into coefficient of x, the whole square. Okay, coefficient of x the whole square, not the coefficient of x square. Okay, so half into coefficient of x the whole square, you add it to either x square plus bx upon a. Now what is this x square plus bx upon a? So it is this initial part that you get after taking a common. You're going to add and subtract half into coefficient of x the whole square to this term. Okay, now that's your second step. Then what is the third step? The third step is express the quadratic expression as sum or difference of two squares. Express the quadratic equation as sum or difference of two squares. Okay, once you get this form, like how would it look like? So that is x plus beta the whole square plus minus alpha the whole square. Okay, it would either look like this, or it could be alpha square plus minus x plus beta the whole square. Okay, so it would look in these two forms, right? Then we have to remember the integral part. Like how will you integrate after you come to this step? So since it is 1 upon the squares of 2, or you can say 1 upon difference of two squares is sum of two squares. If you remember, we did the special integrals in which we had 1 upon x square plus a square, 1 upon x square minus a square. So we can use the special integrals to solve these type after we finish the procedure. That is, after we finish these steps and come down to sum of squares or difference of squares, then we can use that. Okay, so if we have something like integral f of x dx, what is our answer? It is g of x, right? Plus c. And in case the f of x is a binomial, that is the x plus b dx, then how do we write it? It is g of ax plus b divided by the coefficient, right? 1 upon a plus c, correct? Now, if we have integral of f of alpha x plus beta, like the one that we have here, right? X plus b the whole square plus minus alpha square, and alpha square plus minus x plus beta the whole square. Then if you have this in your integration in the final, that is in the numerator. Okay, so we write it as 1 upon alpha g of ax plus b, or alpha x plus b over here, plus c. Clear? This we already know how to integrate. Okay, for our quadratic type of sum, how will you integrate? You're going to use the standard integral formulae. Okay, then use the standard integral formula. Okay, the ones that we did, special integrals, if you remember. Okay, so those we are going to use to solve the sum. So the procedure is clear. That is your first integral type. So what is the integral type? Let's just check. 1 upon ax square plus bx plus c, or 1 upon root of ax square plus bx plus c. Okay. Okay. Now let's go to the next integral type. Okay. So integral of the type So what is the type? It is integral of 1 upon a sine square x plus b cos square x plus c dx. Okay, so now this is not really a quadratic, but we have to change it into a quadratic. Okay, so what's the first step over here now? So let's write down the steps to solve this kind of an integral. The first one, divide numerator and denominator by cos square x or sine square x. Okay, first step. Then second one, in denominator, okay, replace sec square x by 1 plus tan square x, okay, and or cosec square x by 1 plus cot square x if exists. Means if there is any term in the denominator after you divide by sine square or cos square and you get sec square x, you replace it by 1 plus tan square x, or if you get cosec square x, then you replace it by 1 plus cot square x. Second step. Okay, third step, put tan x equal to t. Okay, so put tan x equal to t or cot x equal to t. So it depends on what substitution you have done, you will do the next substitution, so that integral reduces to. Now let's do this much working on the type that we have. So to understand what do you get the end product as. Okay, so it says that the integral should reduce to integration of 1 upon a t square plus bt plus c dt. Okay, so let us see what is the type and try doing these steps. So we'll take the type only directly, 1 upon. Okay, so we have integration of 1 upon a sine square x plus b cos square x plus c dx. Okay, so what is the first step? Divide either by sine square x or by a cos square x. So here we will divide by, let's say divide by cos square x. So divide numerator and denominator by cos square x. Okay, so we'll get integration of 1 upon cos square x in your numerator. Okay, divided by, now sine square x upon cos square x is tan square x, so a tan square x. Okay, plus b cos square x upon cos square x cancels. Okay, plus c upon cos square x, that will be c sec square x. Okay, now let's go to the second step. So the second step says in denominator, so in denominator, okay, remember this, replace sec square x by 1 plus tan square x. So we'll have the integral as 1 upon cos square is sec square x dx. Now remember, do not replace this sec square x, this will remain as it is. Okay, the first term is a tan square x, okay, plus b plus 1 plus tan square x into c. Is that correct? Sec square x will be 1 plus tan square x into c. Okay, so we are going to get integration of sec square x dx divided by a tan square x plus b plus 1, sorry, not 1, it will be plus b plus c, okay, plus c into tan square x. Okay, so now when you simplify this, you're going to get sec square x here as the numerator, and the denominator will take tan square x common. Okay, so we'll have a plus c, okay, plus b plus c. Okay, now if you can see, these both are constants here, and here a plus c could make another constant. Okay, the next step, it says put tan x equal to t. So when tan x is equal to t, then sec square x dx is equal to dt. Therefore, your integral changes to dt upon a plus c is your coefficient, okay, tan square x, so t square plus b plus c. Okay, now it is of the form, you can say integral 1 upon a t square plus b t plus c. Okay, Now there is a difference here. What is the difference? They say bring it to this form or reduce it to this form. Okay, so sometimes you will have the term over here bt, and then you use the previous method, that is the method of quadratics, to solve it, that is perfect squares, completing the squares and then solving it. But in this case, you in the sum or in the solution that we are doing right now, you are only having two parts, that is, let's say a plus c, I call it another capital A constant, into t square plus b plus c as a capital B constant. Okay, so I already have it in the form ax square or plus b, or you can say x square plus b square. Okay, so you convert it into that type. So it depends whether you are dealing with this directly or whether you are getting this as a quadratic. If you get a quadratic, then you use completing squares. If you directly get this value, then you use your special integrals and write the answer. Okay, so in this case, if I have to write it in quadratic form, then it will be t raised to 0. Okay, this is just a basic representation, so don't mix up the a plus c over here with the previous a of the sum. Okay, remember that. When we solve the numericals on the same, it will give you a clearer understanding of the same. This is uh, how you would solve sums on sin x, sin square x, cos square x plus c. Okay, so what are the steps? The third step was put tan x as t, get it to a quadratic, and then you use the previous method, that is the method of quadratics, to solve this integral. Clear? Okay, let's move to the third type now. So third type also is something similar to the one we just did, only there's no square value. That means integral of the type okay, so what is the type? It says integral 1 upon a sin x plus b cos x plus c. Now there is no square, okay? So what is the substitution you are going to do? So it says use, method is same, you are going to divide throughout either by sin x or by cos x, okay? Then you will say use tan x by 2 equal to t, okay? Now, when I say tan x by 2 is equal to t, then its derivative will be sec square x by 2 into half equal to dt. Okay. Therefore, sec square x by 2 is equal to 2 dt. Right? Okay. Now, I am having the term sin x and cos x. So, sin x is equal to, or one second. Okay, now here in this case dx has to be substituted first, so dx will be 2 dt upon sec square x by 2. Okay, sec square x is 2 dt upon 1 plus tan square x by 2, okay, which is 2 dt upon 1 plus t square. Okay, now this is for tan x by 2. There will also be a substitution for sin x by 2. So how sin x, sorry. So sin x will be equal to 2 tan x by 2. We have this formula for sin x, remember, 2 tan x by 2, 1 plus tan square x by 2. And we have one for cos x. What is that? 1 minus tan square x by 2 upon 1 plus tan square x by 2. Okay, so these also can be written in the form of t. So you will have 2t upon 1 plus t square, and this you will have 1 minus t square upon 1 plus t square. Okay, so these are all the substitutions that you would require while you have the sum of the form 1 upon a sin x plus b cos x plus c. Okay, now as and when we solve the sum, I will explain this portion again to you so that there would be a quick revision as well. For now, I will just solve a normal quadratic sum for you to understand this method better. Okay, like what is completing the squares and how do I get to the final integral. So I'm doing one example on the first type. Okay, so I'm writing it over here. Example on first type. What is the first type? Let's put it in brackets over here. Integral 1 upon ax square plus bx plus c. Okay, that is a quadratic directly. How do you solve this? Okay, let's take the first example. Integration of 1 upon 3 minus 10x minus 25x square. Okay, and dx. So let's think about what is the first step that you have to do over here. Divide by the coefficient of x square. Okay, so it is integration of 1 upon, okay, so we are dividing by the coefficient. We'll have, or you could also say taking 25 common. Okay, if you don't remember that divide, so you could say remove the coefficient of x square. So this will be 25 common. I'll have 3 upon 25 minus 10 upon 25 x minus x square. Okay, sorry, dx. Now, next step is take 1 by 25, that is a outside the integral. That was our next step in the steps that we had written. Okay, and write the denominator in the form 3 upon 25, okay, minus sign outside, and I get x square plus 10 upon 25x. Okay. Now we are going to use the completing the squares method. Now what does that mean? So if you can see, I have written it in the form x square plus 10 by 25x. I have the first two terms. What do I require? The third term to complete the square, right? So how do we obtain the third term now? So it says completing squares, okay, right over here, completing squares in denominator by adding and subtracting. What do you add and subtract? Half into coefficient of x, the whole square, right? Okay, so what is half into coefficient of x? It is half into, what is the coefficient of x? It is 10 upon 25. So half into 10 upon 25. We get 1 upon 5 and its square, that is 1 upon 25. So we have to add and subtract 1 upon 25 to our integration denominator. So 1 upon 3 upon 25 as it is, minus sign as it is, x square minus, or sorry, plus 10 upon 25 is actually, okay. So if you have noticed, I have taken plus 1 upon 25 with 3 upon 25, and I have put minus 1 upon 25 inside the bracket with a plus sign. Okay, so now we've completed the squares. We are going to write it in the square form. So it will be integration 1 upon, what is this, 4 upon 25, okay, minus x plus 1 upon 5 the whole square dx. Okay, so this can be written as 1 upon 2 by 5 the whole square minus x plus 1 by 5 the whole square dx. Okay, so this is of the form integral 1 upon a square minus x square dx. So what is the answer for a square minus x square dx? It's a special integral, right? So let's check the answer. The formula list should be in front of you whenever you are doing these special integral types. Okay, so we are having 1 upon a square minus x square. So the answer is, The answer to this is equal to 1 upon 2a log of a minus x, sorry, a plus x upon a minus x plus c. Okay, so what is the answer over here? 1 upon 2a. What is a? 2 by 5. Okay, log of, also 1 upon 25 is already present, which we forgot to write here. Yes. Yes. So the final answer will be 1 upon 25 into 1 upon 2a log of a, that is 2 by 5, plus x, that is x plus 1 upon 5. Okay, divide by 2 by 5 minus x plus 1 upon 5. Okay, plus c. Let's put in a final answer. 1 upon 25 into 5 by 4. Okay, log of, and what are the answers that we get inside? 2 by 5 plus 1 by 5 is 3 by 5. Okay, divide by 2 by 5 minus 1 by 5 is 1 by 5 minus x. Okay, plus c. So we are getting 1 upon 20 log of, this will be 3 plus 5x upon 1 minus 5x plus c as your final answer. Okay, now a few mistakes that we did while solving. 1 upon 25 we forgot to carry over, which you could also forget while solving. Okay, so do not forget that. Also the sign mistakes at plus 1 upon 25 and minus 1 upon 25. Okay, so be careful about that while solving the sum. Now we'll do this type more in the next exercise. If you have any doubts in the example, do write to me. I'll solve another one for you. Thank you so much.